And let's continue with 202, which I mentioned before. This is the most important project in the course for Linux. This one is where you do the basic buffer overflow, which is what you should learn how to do. So let me get it here. I'm going to clear, and we'll look at pwd.c. There. So here's the code. In the main function, it's going to call test password. And test password is going to ask you for a password and read up to 50 characters from the standard input, but put it in an array that only has room for 10. So there can be an overflow here. Then it's always going to return 1. So it's always going to print fail. No possible password will ever be correct. And it'll always return 1. It'll always print fail. You'll never execute this win command. So we're trying to find the magic password that will execute this win command anyway, even though the developer did not provide any way to reach it. So that's the goal. So you compile this thing. By the way, in this machine, I had to use this no pi switch to stop it from making position code that would be relocated in memory. So you probably have to do that on your machine too, to compile it an old way. And so now if I run the program, I give it a short name, like my short password is 1, it just says fail. But if I give it a long password, then I get a segmentation fault. So that's a clue that there's a vulnerability. Now, to avoid going mad, I should disable address space layout randomization. Now, I had it print out an address so you can see this. So if I give it a password of 1, notice the password address was here, 9B6. If I just do it again, it's 906. Next time it's 13B6, D6, so it's changing every time. That's going to be a problem, so I'm going to fix that. Here's the command that will turn that off. Sudo su minus will change me to root. Then I got to put in my password. Oops, now I'm going to be in trouble. I copied and pasted something in there. Probably going to kick me out. Okay. Okay, there, that's the thing that turns it off. Now if I run that program and give it a 1, and run it again, and give it a 1, it's the same every time now. It's no longer randomizing the address of this program. That's what I want. So now we can debug it. And we can do source code debugging just to make life easy. I included the source code in the compiling here. So here's the function that has the buffer overflow, and the buffer overflow happens right here. So I just want to stop after that, but before it tries to return, so I'll break at 9. All right, now we can run it. First we're going to run it with normal inputs. So I put in AAAA. I'll put in 4 8As. Now it hits the breakpoint, so I can do info registers to see where the stack is. And the stack goes from 4B0 to 4C8. So I can examine that. 12X at ESP. I just remember the bottom of it is 4C8. So this is 4C8, and that's the stack frame. Just those few lines. And notice here's the A's I put in. AAAA, 41 is A. So the data I put is on the stack. The return pointer is here, starting with 0804. So that's my target, and there's my A's. So now all I have to do is put in something longer and see where it hits. So I'll put in this thing. So I run it again, start from the beginning. I put in that long mess. Now I do info registers again. And EBP is still 4C8, which is the fundamental problem. Even though I put in a longer password, it did not allocate more room on the stack because that's the weakness of C. And so now 4C8 is here. There's the stack frame, and there it is, 46, 46, 47, 47, hit the return pointer. So that's the part of this that hits. This is 41, 2, 3, 4, 5, 6. So it's the last 2 F's and the first 2 G's are what hit the pointer. So now I know how to exploit the box. All right. And by the way, I can prove that if I continue, it's going to crash with FFGG, 46, 46, 47, 47. So now I just have to choose a location to hit, and that's going to be the win function. The win function is here. That's the address I want. I want to jump there to execute this win function. So I just copy that. And now I make my exploit, which I've already made here, which I think is exploit pwd. Yep, okay, so nano, actually I can just, yeah, let's nano exploit. All right, and I'm just going to copy it onto my clipboard, and you see it's still the same, 080491D4. I've already put it here. So this is the same kind of code we're going to use all the time. We import sys, and we use sys std out buffer write, so we can write an array of bytes. And so I put in the A's up to the first two F's. I put in the 4 bytes to target this address, and then I put in the remaining bytes at the end to keep the total length the same. So these 4 characters here that are sort of hard to read in this stupid color are these bytes backwards, D4, 91, 0408. And you will have to adjust them on your system. This is the #1 question I always get from students. They run the exact code for my example and it doesn't work. You have to adjust the address to hit the right address on your system. So this exploit should do it, and indeed it will. You can see it in the debugger, and you can see it outside the debugger here. If I, by the way, this is kind of useful to know. If you run this thing, exploit, it prints stuff out on the screen, and notice it prints 2 F's and 2 G's. The other characters are all unprintable. So one way to see them is to put it in a file, which is what you want to do anyway, because it's easier to redirect a file into the code. So you do this. That will take the output and put it in a file called attack.pwd, and then you can use xxd to look at attack. This is the way to see it in hex mode. If you don't have xxd, you can install it with sudo apt install xxd. And now you can see after the 4646 comes this. And that's the address you want, 080491D4. That's this address right here, the start of that function backwards. So that means if I run this program, well, I'll just do it this way. If I run pwd32 and I take the input from attack, then I get you win. So it did run the winning function. Then it crashed because I didn't fix the saved EBP. So when I return, it doesn't actually return to main and finish normally. It just crashes. But I did trick it into running the code that the developer didn't want me to run. So, like I say, understanding this and the variations of it are the most important part of the course. You should do this, and I have many versions of this. I spent, like, I had an airplane flight to China, like 14 hours long, and I realized I didn't need the internet. I could run virtual machines, and I developed this whole project on the flight. So I learned how to make scripts for the debugger. So you can do it locally on your machine, and you can do it with 64 bits in addition to 32 bits. It's very much the same process. And then you can start exploiting my server, which is very fun. So if you go down here, here's some. So here's a string processor. This is going to run on my server. So if you give it, say, AAAA, and run a debugger, it's going to show you this on the server. So it's going to show you the code, and notice the code has flags, and I've redacted the flags. There's a first flag and a second flag here. So your job is, I gave it AAA. You can see the registers. It goes from DC20 to DC48. So that is here. Now I gave it AAAA, and here it is. Here's my AAA. A. There's the 4 A's I put in. So if I put in more A's, I'll be able to target this return pointer, and I can make it go somewhere. And so you have to go up here and figure out how to do it. So the first flag, you're going to read this. You're entering a product key, and if you make the 30th character of the product key a 7, you'll get a flag. And so you can do now. Now here's something to understand. This is real important. I wanted to show you this. If you want to put in hexadecimal values, then what you do is you put them up here in the URL. So I have AA. Now I'm going to put in %01, %02, %03, %04. You can put them up there in the URL. And now, when you go down here and look at the stack, here's 41, 41, 40. Here's 1, 2, 3, 4. That's how you do it. So the way I did this, I don't even use the form. I just take that and put it in a text editor like Notepad or whatever you got. On my Mac, it's Smoltron. Here's the text editor. So I design my exploit right here. So to get the first flag, you have to put a 07 somewhere. So I could just start putting in %07 and put a bunch of them in here. And eventually I get the first flag. And then to get the second flag, you have to do the usual exploit. You're going to have to run this function called win. So you're going to have to find it. And this here shows you disassemble win is here. So it shows you the address of win. So you're going to have to redirect execution to go here and run the win function to get the second flag. And you're exploiting my real server. But my server is always running GDB for you so you can see what's going on. So it's pretty cool, and there are variations of that. If you go back here, you do, here's 2 flags here you can find, and then there's a 64-bit server where you do it again, and there's another one here where you exploit a server with address space layout randomization. So you'll see you have to enter data twice, debug it, and then run it. You'll find out where it is each time you run it. And so that's the game here. Notice, by the way, some of these take a string, like A, B, and C. Some of them take a character in hex. So here, if you give it A, and run it, and put it here, A, then, oh, see, I got to go back. There, this is where I have the, all right. Oh, I have to hit the debug button. That's why I'm fouling up. There, I debug it. And now you're going to find that data on the stack, but it's not 41, it's the AA. You're reading in a hex value. I did this deliberately so you can actually put in nulls and other forbidden characters. You can put in any series of hex characters you want. It takes the raw data in hex, so you don't have any limitation on characters like no tabs, no spaces, which is important for this one. So give those things a try. There's a lot of points, that's why I encourage you to do it. That's 202, you got 40 points required and 75 extra. So yeah, that's why it's that way. Understanding this one is pretty much the whole course. Although, the next one to understand is ED308, which is where you just do the same thing on Windows. And you'll learn a little bit about Windows. These 2 projects are the most important ones in the course. 202 is fundamentally how to exploit Windows, or Linux rather, and 308 is fundamentally how to exploit Windows. And everything else in the course is minor variations on those 2 attacks. So that's what I wanted to show you. I'm going to stop the recording.